All right, it is
Shotgun.
go time. Cheers, cheers. Welcome, everybody. It is 2 hours UTC, and it's time again for Astronomy Daily Live. So, welcome. Come on in. I've got some coffee remaining here that is at least moderately hot. Oh, I hear myself. Yay, I must be live. So yeah, I hope everybody's doing well today out there in the universe and the world. Carolina Sky Astronomy. Hey. Yes. I was about 3 weeks late um, with this thing, and so yeah, it was finally. I got to a point in my day this afternoon where it's like, okay, what am I going to do? And so it's like, well, since you don't have anything in particular, why don't you get rid of that mess on top of your head? So yeah, that's exactly what happened. I I and this is just a little aside. I'm going to babble here while we are gathering. But just as an aside, hair is one of those things that I'm not exactly sure why we have it. I guess it's just inherited, but we as humans definitely do not need it in any way, as far as I can tell. So it's just I guess supposedly it's just an inherited thing. It's how we evolved, and so we've still got a little bit of that left, and but I don't really understand what the point is, but I also find it very, very interesting that the two things that um, continue to grow, uh, our bodies in general, grow, and then they stop growing at some point. But there are at least two things that continuously grows, and that is hair and nails. Hey there, Tim. So
Hey,
I got
Cosmic.
to, yeah. Hey, all right. Well, I will continue my blathering here in just a moment. Since I already said howdy to Tim, gotta say howdy to Bobby. Hey.
Hey. It's kind of a bit crazy when the women can whip their hair back and forth, but we can't.
No, that is one of the many things that it's like, if you want to wear it long, if you want to wear it short, if you don't want to wear it at all, it's, in the words of Fred Rogers, it's you I like. So if you want to wear it short, long, pink, red, orange,
And
green, whatever.
yeah, if you don't
Whatever.
like me, there's the door. Get the heck out.
That's it. Exactly. I don't like you because you have short hair. I mean, so what? That's
There's Otto
ridiculous.
Lenta, Tom Van Scotter, and Jim. Hey, what's up?
Hey, nice to see everybody over in the chat. So yeah. So another cloudy evening here. Got some.
Sad.
Yeah, sad. So got some pretty thick clouds, not really anything rainy or anything, just like pretty thick high clouds, and they're
Oh,
just
I did check the passes for ISS. I'm not gonna have a good opportunity to catch those SSTV images.
oh, that's too bad. Yeah, well, you've gotten them in the past, and um, you will again. But this next series of passes, you're not going to be able to see them.
Yeah, I think
Oh,
the best time in that window that might be good. It's going to be a 5-degree pass. And what you going to do with a 5-degree pass?
yeah, yeah. Are there any daytime passes? Did you check that?
How about daytime passes?
Yeah.
Yeah, but yeah, they give you a small window per day and stuff. It was like just like the last window of opportunity is going to be tomorrow. It's going to be like roughly in UTC terms today from 1400 to 1900. But like I said, in that small window, I may have a 5-degree, but what's the point?
Yeah, that's I mean, you'll get a signal, but it's probably going to be super noisy. Super noisy. So, yeah.
Yeah, and you might
Yeah.
not be able to catch it at all.
Right. Right, right, right. So all right, well yeah, so yeah, Cloud's here again, and
And
uh
yeah, Jim, I think he's never gonna make you want to fart, just like he's gonna make me want to fart.
ah, ha, ha, ha.
Well, don't get me wrong. My my great aunt had a mug on the side that says "Please don't smoke," and you lift up the cup and it says, "And I won't fart."
Ah, you sick humans. I don't know about you. Cheers to everyone.
Oh yeah.
Mm, good stuff. Atta, I hope everything is going well for you out there. Sounds like you're sort of back from your latest travels. So very very cool. Yeah, excellent,
Yeah,
excellent.
I heard Dizzy Sue is not feeling well again.
Ah, well, keep getting better. Just that's all you got to do is just keep it up.
Yeah, that's about it.
That's it. That's it.
Yo, Mark Antonio's on.
Yes, he is. I was logged on to his live stream for a little while there, but I got to jump over and do this. So I just politely jump off and yeah, I'll probably jump back on over there if they're still going. So yeah, that's a good possibility. So yeah, and Carolina Skylar's
I don't
telling
know
me it was
about
over there
what
too.
Tim said. Going to ring in the doctor in the morning and give him a right old bowl locking.
Hmm. That
I hope it doesn't come with an escalation and stuff.
yeah, I that that doesn't sound it doesn't sound extremely nice. So yeah, you got to do
Yeah,
what you got to do
yeah. At least
for sure.
my doctor looks like he's old enough to retire, but he can still help people.
Yeah, absolutely, absolutely. So yeah, I started looking today at the actual data I collected from XY Canis Minoris, the eclipsing binary star that I actually collected 1,000 images that went from, I don't know, maybe a half an hour or so before the eclipse started through to what looks like, and I'll show you the plots here, what looks like just past minimum. which is exactly what I was hoping for. That object was very, very rapidly setting. So I'm really, really glad I got what I got. And preliminary look at it, which I'll show you here, looks
Yeah.
looks interesting, but there's a, a weird problem that I'm not quite sure what it means yet. So I will show you that too. I was also able to improve my stacking software a little bit. Actually, the parameters I use to stack, and out of the 1,000 images that I grabbed, I was actually able to use 954 of them. So I lost 46 images due to, poor tracking, or the telescope still moving. Cheers.
Yep,
Cheers,
I
yes.
can see Tim got his cider. I got my faucet water.
Excellent. So only lost 4.6% of the data, which I can live with that, right? I can try to get better, but I think that that's probably about as good as it's going to get, and it's going to vary. It's going to vary depending on uh, uh, how well the star alignment did that time around. How well is the pointing? How well is the tracking? That's going to vary, I think.
Well, let's forget to say hello to Brazil to Ingrid Asa.
Hey there, Ingrid. Nice to see you there too. Atta has got a couple of glasses of wine there, so that's pretty nice too. So cheers.
I don't know how
whatever
to say
you've
hello
got
in Portuguese, so sorry about that.
I think it's just hola. I think it is hola.
Yeah, like I said, I kind of forgot.
I don't know. I'm terrible with languages. I've got enough trouble with my own.
Hola, bonjour, bonjour, como estás, muy bien, ça va bien.
Very cool.
That's it.
So yeah. So
hola.
I was able to.
Hola, Ingrid.
Yeah. Hola, Ingrid. And so I was able to make a new stacked image using 954 individual images. Each image was a 3-second exposure, so it's almost a 50-minute long exposure, and so yeah, we looked at that last night, but there were actually I was missing probably a couple of hundred images, so I wanted to try to improve upon that, and I did by a large factor. So yeah, I'll show you that really quick, and then we can get into some of this other interesting, really, at least the first part of this live stream. This is just a warning, right? We're going to go serious nerd here, like really serious nerdy stuff. So just a warning, it's going to go deep nerd tonight. So
I'll be above
all right.
my head then.
It's gonna
just
go
a warning.
Down for
just a
real.
warning. It's going to get down into the muck. Yep, for sure.
It's going down for real.
Deep and dirty.
Deep, just really nerdy. Just nerdy. Nothing really dirty about it. Just incredibly nerdy. Yeah. So that's just a warning. Here, I will share my screen, and you can see the new deep image. So this is the deepest image, meaning the longest exposure that that I've got
The
on that
first
guy.
cut is the deepest.
Excuse me.
Yes. And here again is DS9. So great tool. I can just come around here. You notice the that going from bright to dark isn't quite as much anymore. So those extra 150 images sort of rebalance that a little bit. But so yeah,
Why are
that
the
looks pretty
frames
good,
in
I think.
rotation with each other
Last
so much?
M42 shot, he had 500 frames to start. Now after going through them and getting rid of the ones with the elongated stars, he ended up with 250 frames.
Very cool. Very cool. Yeah, I'm going to look at that too, just to make sure. 300 frames. Yeah. Yeah. And that's exactly the situation that I've got too. There was some kind of tracking thing, right? I mean, what I did in this case, and Tim, I'm gonna answer your question because I actually heard it.
I did wonder.
Yeah. So
I'm trying to be quiet here.
What I do to stack these is I designate a reference image, and I usually use the first one. Now I don't have to, but I usually do, and I say, okay, and I'm going to zoom in a little bit here. At this location, XY pixel, and at this XY position, I want to have a star. I'm going to turn Tim down a little bit. Right, there we go. So at this location on the image, I'm going to have a star. And at that location, I'm going to have a star. So that creates a pattern that I can then go to the next image.
I don't think if you saw the fireball as well, I think I got one around and you got one around.
Someone here saw the fireball crossing the USA. No, didn't hear about that one. Didn't hear about that one, Ingrid.
I know that one of the amateur radio satellites re-entered last week.
Very cool. One of the things that we need to do, and maybe we'll do this. Maybe we'll do this today. There's a really nice meteor detection network that I like to go to from time to time. And if that thing happened a few days ago, and it's something that was visible from this network of all sky cameras that are looking for bright meteors, then it's going to show up on those. So maybe we should go over and take a quick look. Let's finish this, and then if there's time, we'll go over and take a look, because that's always interesting.
And don't get me wrong, there's always time.
And there always does seem to be time. Yeah, for sure. So
it happened. Yeah, it happened on March 30th.
Okay. Well,
But
we'll take a look.
Deep Sky Dude in the chat as well.
Hey there, Deep Sky Dude.
And what's also good about that, you can see the chat as well.
Yes, that is nice, isn't it? I'm going to just move this over here because then there we go. There we go. Tim, you take care. Come on in anytime. You know that you are welcome, but you got to take care of business. So do it, dude. Yep.
Can't just work overtime.
Nope. No, you got to work all the time. That's what we do. Yep. Anyway, so yeah, these.
Yeah. Good night, Tim.
Yep. Good night. So yeah, to stack these, I have to find this pattern in every single image, and then I have to shift and I have to rotate, and that's why these don't all line up. There are some images that extended over this way, some of them extended that away. So there was shifting because of the tracking, and there was field rotation because I'm on an altitude azimuth mount, and the sky is an equatorial sky. So there is field rotation.
Oh my gosh. It's still freaking April Fool's here in America.
It is. It is. It is. It is April 2nd, UT time, but here, I think in the Western Hemisphere, more or less, I think we're still on April 1st.
They'd have to be true, Jim.
Yeah, Jim, I've got an interesting story about that. Maybe I'll relay that at some point in the future. So yeah, I've got an interesting story about that kind of a topic. Anyway, so this still looks really, really good. I haven't looked carefully enough to see if I can see anything more or new, but for the most part, I think that looks pretty darn good. So I'm pretty happy with that. That's
hey, what's up, our Instro?
Hey, our Instro. All hail the Taurus, yes. Absolutely. Yeah, that geometrical configuration, I think we're going to be seeing. We just need to look for them, but I think that we're going to start seeing those kinds of things everywhere. So yes, if you like donuts, you are set, right? Because I think the universe is full of them, for sure. All right, so this looks really good. Yeah. But what I'm really interested in is this star right here. So this star is XY Canis Minoris, and it is that eclipsing binary star. So this is a long exposure, but if I look at the brightness of this star in every single image, in all 1,000 images or 954 images, what I should see, if I caught the eclipse, is I should see an indication of that. So that is the ultimate goal here, right? There was a secondary goal to get this really, really deep image, just to see, what I could see. And like I said, I think I'm still seeing. I'm easily seeing.
How long are the exposures of the frames?
So the exposure times are 3 seconds, and it took about 4 seconds to download each image. So yeah, the whole thing takes about 7 seconds. So yeah, I ran that for quite a long time. So yeah, like I said, a secondary
Now,
thing.
out of my curiosity, you never tried your CCD soft on with wine instance before, huh?
No. I like I said, I've got a system that works, and I'm going to leave it alone.
Yeah.
I'm going to leave it alone until either something breaks, and then I'm completely SOL, or I do an upgrade. Either one of those is going to happen.
Yeah.
I
I just
guarantee.
thank goodness about my Chromebook that I've modified it so I can do my radio apps.
Yes, absolutely. Anyway, but my primary interest in this eclipsing binary star, of course, is to catch the eclipse and to measure the photometric light curve, right? So brightness versus time. And I'm using this bright star as a reference star. So this star supposedly isn't changing in brightness at all, at least while this thing is going through its eclipse. Okay, so this thing isn't changing in brightness at all. This one supposedly is. And so if I look at the difference in magnitude between these two stars, I should see this one dim in sort of the characteristic way.
Yeah.
Right? So that I'm going to show you momentarily, but so this is where it starts to get really, really nerdy, because this is my software that I am writing and working on. I can output all kinds of really interesting information. Sort of, I've come to call it telemetry, because it is telling me what its situation is, what it's doing, what it's having to do to extract this data. And so one of the things that, well, there are lots of things I can look at, and some of them I actually do, and I write them out to a file that I can then plot, right? I print out numbers that are corresponding to something, and I can write those out to a file, and then I can use GNU plot to plot them. So I thought that I would show you a few of those. So probably the easiest to understand one is the field rotation. So, like I said, I use these two stars as a reference, and I calculate how much I have to rotate the each corresponding image in order to properly stack it onto my reference image. And so I have to compute that angle of rotation. And so that's one of the parameters that I can actually plot here for you. I've actually got this all set up already. Let's see if I can find it. I think it's this one. So this is the Julian date down here, right? So it's time. This is time. And then this is the rotation angle in radians. So
now, how is Julian date calculated in traditional standard times?
Oh, I knew that you were going to ask me that. Bobby, I honestly do not. I do not remember. The only thing that I do know is that it is currently Julian date about 2,450,000. So these digits down here actually just represent the, well, upwards of the last 1,000 days. So this is Julian date 2458571.68. And then here's 0.7, here's 0.72. So you can see that this entire data set took about 1/10 of a day. It went from about 0.68 to about 0.78. So, but this is showing the rotation angle that I had to apply to each image in order to properly stack. And as you can see, I was a little bit surprised at this. I'm going to have to think about it a little bit. The rotation angle isn't constant. It's not a straight line. It's a curved line. So yeah, I'm going to have to think about that a little bit. But at least according to the calculations, they're very consistent. So I would say that the precision here is pretty good. But I wasn't aware that the rotation angle changed as a function of, in this case, time. Now, I think in this observation log, let's take a look here. I think I have, I do. Yes. So I know this is hard to read, but if you look at column 5, so 1, 2, 3, 4, 5, this one, where it says 1.225193, then 513. So this column is the air mass column. That's the air mass is a function of elevation. So as you can see, the air mass increases as the elevation goes down. So the air mass of an object at zenith has an air mass of 1. And at least according to the math, an object on the horizon, it has an air mass of infinity. Of course, that's not possible, but it's very, very, very large. So as you can see, these numbers are increasing very, very slowly because each line here is one image, and I was taking one image about every 7 seconds. So the air mass isn't going to change all that much. But I'm wondering if the what the relationship is between the rotation angle and the air mass. Let's see if there's a difference. So I'm going to do column 5 here instead of column 3. Let's see what that does. Ooh, it makes it even stronger. Interesting. Okay. So you can see that there are some gaps in the data, and that's just where, for one reason or another, I threw that image out. Are there shenanigans in the chat over here? Oh,
Yeah.
probably stop yawning. That's all right. You know, it's
a busy. It was a busy day. It was also my first check day.
I think that if you can't relax during this live stream, then I'm doing something wrong. So I actually consider yawning a compliment, that you're nice and relaxed and just chilled and just having a good time, right? So I think it's great. I think we should all yawn a little bit more. So yeah, no, I think that's absolutely great. You know, if this was a classroom or something, that'd be like, you know, pay attention now, right?
Yeah.
But it's like, no, we're chilling. We're chilling. Anyway, so yeah, the rotation angle is even a steeper curve when it's a function of air mass. So pretty interesting. One of the things that you might notice is that there are some dots here that are way off the line. Here's one up here. It's kind of hard to see. That are just way off the line. And
I don't think I have a coffee command or Astro.
I don't know if I have a coffee command or not. I probably should. So I think these guys, and there's only a few of them, but I think that they are actually, I think we can actually see them. I think that's what these little ears are here. They're really, really, really faint. So they're hard to see, but they're showing up in this other bright one. Look here. Let's zoom in here. I'll show you what I'm talking about. So you see this bright star here, and you see these two things on either side, just like up here. So I think that these guys are sort of leaking in because, you know, those rotation corrections weren't quite right, and it's pretty small angles, you know, we're dealing with here too. So yeah, that's just sort of my thought. I'm gonna think about how to maybe remove those. I should be able to do some kind of statistical thing on this curve and eliminate the outliers. So yeah. But anyway, so that's one parameter that I like to track. The other parameters that I definitely like to track are having to do.
Your chat is giving out some command suggestions.
Okay. Yeah. Yeah, that's funny. There are two other parameters that I like to save, and that's how much I have to shift each image to properly align things. So that is speaking to, you know, the tracking of the telescope. I'm going to take a deep drink here. So what I'm going to show you next is what the telescope mount is doing, and you know, of course, I'm having to intervene to correct it. You know, I'm always having to move it around to, you know, to make sure that, you know, the target and the reference star are both in the field of view. And it moves around enough, that sometimes I lose it, and I have to move the telescope around, and that smears out a couple images. So, you lose a few. But so here, I'll show you those. Probably the way to do it, trying to think of the best way to show you, because I've been looking at this already, as you can see, and I want to give you the best view, but I want to also sort of show you my path through this. So let's look at the X correction, just the X correction, and I think this is the one. No, that's the Y correction. Let's do this one.
So Jim, when he gets up in the morning, he's gonna get up to shoot Jupiter and Saturn.
Very cool. Excellent.
And he's gonna actually take a shot of his super large coffee cup.
Fantastic. Would like to see it, for sure. All right, so this.
Like a tornado.
Yeah, so just let me explain what this is. So along this axis is time. So it's the same Julian days, right? Here's 68 to 78. And this is the amount of X shift, essentially azimuth motion. So you can see that it, as time goes by, it's sort of wiggling around. Here is probably a correction I made, right? I grabbed onto the paddle and went wham. And then it drifted that way a little bit more, and so I pushed it back again, and then it drifted, and then it's like, okay, I'm going to scooch it way over, and so, way over here, it drifted, it's like, oh, that's too far over, I'll put it back. So you can sort of see how the tracking drifted left to right in this plot. And I can show exactly the same thing with the up and down motion. And this is where it gets really, really interesting.
The science soda.
Yeah, so here's time now, and here's the Y motion. And as you can see, there's a periodic motion there. Pretty interesting. Now, for the most part, this is me having to push it back into the field of view. So it's moving generally upwards this way, and when it reaches a certain limit, I push it back down, and then it drifts back up, and then I push it back down, and it drifts back up, and I push it down. So that's what's happening here, is that it's drifting, and then I push it back down, and then it drifts again. So except in this area right here, see where that's just nice and smooth curves? This is the telescope tracking all by itself. I didn't intervene here at all during these smoother things. This is telescope drift in the Y direction, in the altitude direction. So I can sort of zoom in on that a little bit. Let's go from 74 to 765. 74 to 765.
Let's see if
74.
a can of Coke is going to make me want to wake up.
765. So there, I've just sort of spread that out a little bit so you can see a few more of the details. So pretty interesting that it has this kind of motion, and this is just free telescope tracking. This is not me intervening at all. So it's
there's also no
this.
internet involved.
No internet. No, absolutely none. So
what I do most of the times when I do my digital stuff,
yeah,
on the radio, it's just plain old software defined with CB, no internet at all.
Absolutely. So what we can do is we can actually look and see how much time has passed between these peaks, because it looks very regular. Yeah. So let's do that. I need to have this live. So let's look at this first one, and I'm going to guess it's about there. So I'm going to say I'm going to take the last four or last three digits. Those last ones over past the decimal. So that's 741. So 741, because nothing else is going to change. This one's about here, so 746. 746. As I said, we're going to nerd out here. This is what it's all about. Let's take the halfway point. It's not quite the peak, but let's just take the halfway point here. So that's about 752. 752.
Man, he's doing some good hacking.
This one here, 757. 757. 757. And this last one is, oh, it's about there, right? So 762. 762. Okay, so now let's look at the difference between these, between the adjacent ones. So this one's a difference of 5. This one's a difference of 6. This one's a difference of 5. And this one's a difference of 5. Yeah, 6 minus 1 is 5. 12 minus 6 is 6. 7 minus 2 is 5. And 12 minus 7 is 5. So let's just take the average of those four distances, right? So we just measured the distance between here. We have to keep in mind that it's the third decimal point. That's all that we have to worry about. But it's just the distance between here and here. We measured to be about 5. Between here and here, we measured to be 6. Here to here is 5, and here to here is 5. Okay? So let's just take the average of those. Grab my handy-dandy calculator. So 5 plus 6 plus 5 plus 5 divided by 4. That'll be the average. So 5.25. So we have to take into account now, of course, that that is the third decimal point. So let's divide this by 1,000. So the time between here and here is 0.00525 days. So let's multiply that by 86,400 seconds in a day. And then divide that by 60. And we get 7.56 minutes. So every 7.56 minutes, I don't know what this means, right? But every 7 minutes and 33 seconds, this thing is correcting itself. Well, it's gone through one one cycle of correcting itself. It's actually about half that time. So every 3.78 minutes, this thing is trying to correct itself. So I just think, you know, that's extremely nerdy, but I think it's kind of interesting, you know, to see the system doing something like that. You know, I mean, that's a behavior that's kind of interesting, you know, to discover. So, but yeah, another thing I can do here is, and I actually already had, is actually do a three-dimensional plot. So we can look at the X and Y motion at the same time, simultaneously, over time. So let's do that. I think that's this one. So there we go. So, well, here, I'll rotate it around for a little while here, let you get. So up and down is time. The z-axis is time, and it's going from the start.
And late for you, huh, Chuck Naglum?
Hey there, Chuck. So the beginning of the observation is at the bottom, and the end is at the top. And one of these axes, let's see, which one is it? This axis. Well, this axis is the X motion, and this axis is the Y motion. Yeah, that makes sense. So you can see, if I sort of line this up straight like that, we see just the X motion. And if we rotate this around 90 degrees, we see just the Y motion. That same sort of sinusoidal thing. But then, of course, this is a 3D thing, so I can do all kinds of rotations here. And it's kind of interesting to see, you know, the structures that arise from that. It's kind of, you know, artsy in its own way. I just like to grab it and rotate it around. Let's make these a little thicker. Yeah, that's not quite as good. Like that.
It looks like you were using like a dry erase marker with that one.
Yeah, yeah. Actually, a line width of 1 is just about right. I like it. Anyway, so that's what's going on with the telescope tracking, and this you know, I'm not quite sure why there's X motion like that. You know, it seems to be wanting to wander to the right. You see, you know, because I'm always correcting it by moving it left, and then it drifts right, and then I move it left, and it drifts right. See that? So it's wanting to move left to right. And then in the y-axis, which I'll get lined up here again, this way. Oh, too far. Here we go. And yeah, actually, I need to. Oh, I don't think I can. Yeah, I can't do it exactly the same way. Anyway, in the y-axis, there's a tendency for it, I think, to be going up. So so up and to the right is what it's tending to do, and I could understand the wanting to move up because it's being pulled down. It's being pulled down by my camera, so it is tilting up, and I think that's probably what that is. All right, well, cool. So anyway, that's just a little telemetry there. I can hear Bobby whispering something, but I don't know what it is.
Yeah, I didn't save enough money on my card, and it got and one of my subscriptions got declined and stuff like that, and it's tuned in. Nice. So there's always a plan B just in case.
Yeah, bummer.
I mean, if you know like your radio sources and stuff, then why do you need tune in?
True. The other thing that I measure in this observation log is the distance between my two targets. I want to see how consistent that distance measurement is. So that's another thing that I can plot here.
And that's what you also get when my friend could have waited until Wednesday so I could give him the money to get tickets to see some more local wrestling next month.
Point type 7, point size 0.5, and color black.
And welcome back, Igor, by the way.
Welcome back. So here is time again along the bottom, and this is the distance between those two bright stars. And as you can see, it's pretty consistently, around 190.4. Pretty consistent. It's kind of interesting that it's a little scattered at the beginning and a little scattered at the end, and getting actually pretty tight here right in the middle. So what does that mean? I'm not sure. I'm not sure what exactly I'm seeing here. I mean, I'm seeing some kind of noise, but I'm not quite sure what the cause of that is. So got a lot to think about. This kind of telemetry, offers me insight into, at least an understanding of what the system is doing, and maybe gives me an opportunity to change behavior or change how I'm doing things, or something to improve. So it's too hard to tell, but this isn't bad.
For Ingrid, wait quick, can we see what kind of meteor activity that the IMO's got right now?
You know what? We can do that. Let's take a quick look, and actually it's not going to be the International Meteor. What's the O stand for? Oh, I don't know.
Organization or observatory or something?
Organization, I guess. Yeah. No, we're going to look at the Fireball network. So let's do that. I'm gonna bring you back here Because yeah, I am noticing what time it is. Thanks for letting me know that we wanted to take a quick look at that. I can show you my nerdy data all day, but I won't.
Yeah. It's like this song. I can do anything for love, but I won't do that.
Yes, but 2 out of 3 ain't bad. Let's see. This is called the Fireball Network. If I can, there it is, the NASA All-Sky Fireball Network. Okay, so here we go. Now, the coverage on this is not very good. So these things have to be seen in order for this network to be able to detect it. So I don't know where it was, but let's take a look anyway. So here it is, and I'll post the link over on the chat so you all can. Our instro got the reference. Very good. 2 out of 3 ain't bad. Anyway, so here is the network that they.
Now this is actually for 24 hours, right?
Well,
because when it served, it was actually on the 30th of March.
Yeah, that's okay. We're good with that. Let me make sure that I'm doing that. Okay, here we go. Where are we? We're here. Okay. So here is the network. So if the fireball occurred over here, or over here, or anywhere but within these.
Looks like it just may have happened at your alleyway.
Yeah, well, we'll find out. We'll find out. So, so it happened on the 30th. Is that the 30th UTC or the 30th local time? That makes a difference. Don't know that.
I don't know. Ingrid, was it the 30th UTC or the 30th, like, Brazilian time?
Because that's.
I'm not sure. It crossed the Californian sky, so I'm assuming Pacific.
Okay, so it crossed the California sky?
Yeah.
Oh, I don't know if this network is going to see it then. Let's see what we've got. It looks like there was activity seen. Here's a pretty bright one.
Yeah.
Let's see which one.
And I would like to say goodnight to Atalinta.
Good night, Ata. Glad you could come by again. Come on by anytime, So I'm trying to figure out where this particular, because this one's pretty bright. See that? It's not incredibly bright, but I don't know which one this is. I don't really know how to even tell. Let's go back and open in a new tab here, because there is a bright one, but I don't know.
I don't know if maybe if you could blow it up, and maybe if Angry can say yes or no or something.
Yeah, it's an AVI file, so let me save it somewhere here. Oh, it says it's a PNG.
We're gonna say goodnight. Good night to Jim. Oh, you can open PNG. Should be able to open PNG.
No, I want the AVI. I want the movie, because otherwise it's just going to open up this little tiny thing, and we're not going to see
Nothing
anything.
else.
Yeah. So we're going to do this instead.
Also, thinking about when I do some ship tracking again, I might be listening to some parts of space.
Yeah, so that was pretty, not incredibly bright. I don't know if you're able to see that or not. And again, I'm not quite sure how to identify these. There's obviously the time here, but there's also down here there's some kind of something, but I don't know what that is. I don't know where this is located. That doesn't look like a serious fireball, though. I mean, it's bright, but it's not insanely bright. So that's probably not it.
Yeah.
Probably not it. Let's go to the 29th. See if there's anything really, really bright here. It doesn't look like there's anything really bright here either. So yeah.
It might be, I don't think California. So I don't know if California has a deep sky, or fireball Alps.
Well, we're looking at the map, and for sure, there's nothing in California. I was hoping that maybe these Arizona ones might be able to see that.
Okay, there's some YouTube videos, but you can try searching around YouTube.
Yeah, of course.
For that fireball.
Yeah. Anyway, this is a really, really, really great website. If you're interested in these kinds of things, they actually let's go back to that one. They actually do this really, really great analysis, and which is definitely kind of hard to see, but I'll zoom in. So this is I can't say that I'm going to know what all of these mean, but I'm going to try to remember at least. So this is the location in the sky, right? North, south, east, west, zenith. Yeah, this one, I don't remember what that one is. This is a so time, right? Frame versus brightness. And so you can see that for this guy, at least, this long one here, it was pretty busy up there. I mean, I'm not quite sure what the wiggling is here, but that's a real deal, I think. So perhaps it was spinning. We can look at that folder again, or we can look at the movie again and see if we can see that. I don't know if you're going to be able to see it really well. Yeah, it's kind of hard to see.
You know, it's kind of crazy you got your BLC in a continuous loop, though.
What's crazy about that?
Nothing. I'm just saying.
Well, you know, if you want to see something over and over and over again, you gotta loop it, right?
That's it. Because those are very short videos.
Very, very short. Yeah. So I'm not seeing anything. This is really subtle, but it's kind of interesting, right? How it seems to even be doing it as it's getting brighter, and then it does it, and then look, it stops. It stops for a little while, and then it goes again. Interesting. Interesting. And this is the other one, the other location, which was a shorter path and, you know, not quite as bright, not as many data points either, for sure. So can't really tell if it's wiggling or not. But it's kind of interesting too. It went from, you know, really faint, and then it pretty much maintained the same brightness as soon as it got up there. So it didn't, you know, fade or anything. It just stayed. So wow, that's kind of interesting. Kind of cool.
You know, the Earth is one tough cookie to survive all those things.
Oh yes, absolutely. So this is the path over the Earth. So actually 110 and 33. Wow, that's actually really, really close to me. So yeah, that's like scary close to me. I'm at negative 110, 32. So I'm right here. So dang. So yeah, I think I would have been able to see this. Oh man. Oh well. That's how it goes. It's hindsight. They actually go so far as to try to create an orbit for these things based on this path. And I've got a serious gripe with these. You know, this path is maybe a few kilometers, maybe a few tens of kilometers. This orbital path is millions and millions of kilometers. You cannot, with any certainty whatsoever, calculate the orbit of this object before it hit the Earth. You can't do it. This is you know, it's totally just it's really, really, really bad to show that, because it's not that it's wrong. They took this data and they fit it to a model and they got this orbit, but that model has nothing to do with reality at all, because it doesn't take into account that you have such a small amount of information here. You can't possibly project an orbit. There's just no way to do it.
Not a chance.
Not with any certainty, right? You can do these kinds of things and follow a model, but it's totally bogus. It really is. So they should just get rid of those plots, because they drive me insane, because they're totally bogus. Totally bogus. There's no way. There's no way. There's just not there isn't enough data here to give you a good orbit. There's just no way to do it. But you will get an orbit. But is this the orbit of that object, you know, before it slammed into the Earth? Absolutely not. No way. Impossible.
All right,
We
good
have
night,
no way of
Ingrid.
knowing. All right, Ingrid, good night. I'm just ranting a little bit because I don't like giving out false information, and that's what this is. This is false information. And I don't like it. But it's pretty nice otherwise. It's a good analysis. You can watch the little movies, and they have an archive of these. I think there are ways of going back even further. But yes, you can look at yesterday's events. And if they're seen by one camera or two cameras or three, whatever it is. It's probably not going to be seen by all of them, but if it's seen by 2, then they'd be able to triangulate and get a distance and a height and all of that.
Just by using those cameras.
Yeah. So here's another relatively bright one. Let's take a look at that. We can.
You're just re-downloading that. Oh, there it goes.
Yep, there it goes. So yeah, here it is again, and here's the light curve again. We actually have two nice light curves. But this one, it looks like it brightened, peaked, and then dimmed. And don't see a lot of oscillation, maybe a little bit here. But let's watch the little video, and then I think I'm gonna get on out of here. Okay, so it saved it to like almost exactly the same named file. Yeah, there it goes. Ooh, so that's pretty bright. It peaked really bright there. Here, I've got a little zoom in tool here. Let's, is it this one? Active zoom. And then we can,
it's not going to let you. I don't know why.
Oh, because of the loop, I think. Let's see. Yeah, it's because of the loop.
Yeah,
anyway,
and it's a shorter video as well. It's not going to let you do it.
Yeah. Dang it. I might be able to. Oh, it's not going to let me do that. Anyway, it's a bright one, and it does dim out at the end there.
You can try like slowing it down, and maybe you'll be able to do it that way.
Yeah, that's true. All right, and again, you know, they show an orbit. It's bogus. Everything else on here, is data. You know, the triangulation based on, you know, where they saw it in the sky. That's based on data. This, I forget exactly what this is. This is data. This is data. This is just fake. It's garbage. Okay, well, on that garbagey note, I'm going to stop sharing, and yeah, I think I'm going to get out of here for today. Let me check the chat really quick one more time. Nice. Yeah, we'll have to find out where that bright one occurred, because you know, if it occurred where this network could see it, we'd see it. But I don't see it anywhere on their little list. So, all right, everybody, I'm going to get out of here for now. So have a great evening, a great day. Subscribe if you haven't already. Thumbs up if you so desire. Make some comments. Spread the word. Spread the word. This is an ever-growing community here, and it's just great fun. You know, I'm getting together every day and chit-chatting all things astronomy and space and science and nerdy things, and just have a great old time. So, all right. Well, for now, I'm going to get out of here. Peace out, and I will see you in a little less than 23 hours. All right. Take care, everybody. Bye.